Hello all, welcome to my channel. I'm back with a new video. In this video, we will be seeing how we can run Spark code on Snowflake. This video is, I'm creating this video because few people have asked me what is this new features launched by Snowflake that allows Spark code to get executed in the warehouse of Snowflake. Before we start into this video, uh, I would like to say a few things about Snowflake first. So Snowflake is a cloud data warehouse solution where you can you can keep on running your workloads at an very faster and optimized scale. Plus, it allows external tables and so it's a lake house platform kind of, and it has a concept of warehouse. So warehouse is nothing but a virtual cluster. It's virtual to us, but it's actual a cluster which runs on Snowflake's account. And what it does, it basically is it will create the resources, VMs, their intercommunications and runtimes, everything, and then allow us to run SQLs on those clusters. So coming back to this Spark on Snowflake thing. So Spark was this was a very demanded or requested feature to Snowflake that can we run direct code Spark code onto Snowflake. So earlier Snowflake had a service called Snowpark, which was something similar to what PySpark does, but it was an engine which was built for uh, for Snowflake. It was not a one-to-one mapping between PySpark and Snowpark. So, and if you have a code which was written in PySpark, and if you want to run using that same code in Snowpark, you will have to rewrite that code. So that was a challenge, and that's why adoption of Snowpark was not that what you call encouraging. And Snowpark did support Python, I think, and some other functions, like I think JavaScript was also supported to create custom UDFs. So in that way, Snowpark this demand to run Spark code kept on increasing. And in 3.4 of Spark release, Spark provided an option of running Spark as a client and server architecture. Earlier, how we used to run Spark was not on a client and server architecture. It used to be a big, bulky, fat jar that you have to install both on the client as well as on the cluster. So Spark team decoupled this architecture so that you have a thin client which runs on your system, and then there is a client which is running on the cluster. So there is a now client server. So client is your Spark Connect client running locally, let's say from your IDE, and there will be a Spark Connect server running on the cluster, which will spin up drivers for you and executors as well to process your data. And the communication happens over between this client and this server happens over gRPC. So this is what it says. It's how it's there. So you have ID. You can connect it from PyCharm. Or you can even write your own. I mean, you can write code in other languages. For example, as of now, Rust and Go is supported. A few other programming languages are getting supported as well. So now you can write using Spark Connect. You can write your Spark application in the language that you are most comfortable with. For example, if you are coming from Kubernetes background and you have a good understanding of Go language, you can now write Spark code in Go, and that will get processed on the server. So this building upon this Spark Connect itself, uh, Snowflake is now offering this solution which allows us to run Spark code on Snowflake warehouses. So how it works is they have built a client and server which is called Snowpark Connect client and Snowpark Connect server, which is nothing but a wrapper on top of the Spark Connect and Spark Connect server. and the reason they have done is that they want to have the compatibility between Snowpark and PySpark, and they don't want to change their runtime engine. So how it works is in Snowflake is that you can have your client, for example, we can run Airflow, Snowflake notebooks or Jupyter notebooks or VS Studio code, VS Code. And here what will happen is we will be running a binary which is called Snowpark Connect. That binary starts a Snowpark client locally, and that local connection gets connected to the Snowpark Connect server, which comes up on the warehouse. When we launch a warehouse in Spark Snowflake, we have option of choosing the newer version of warehouse for warehouse 2.0. That's the requirement that you to have Spark support in there. You have to choose Snowflake warehouse 2.0 version. So once we create a warehouse in there with Spark support, there is a Snowpark Connect server running. Clients get connected to that, and what happens is we send the data frames or SQL or UDFs from the client to the cluster, and it talks to the data frame API. It parses the SQL. Same Spark query planner is invoked. How it works in Spark, similar to this one, like analyzer, optimizer, scheduler, and distributed engine. So the below two ones are the ones that changes in here. So what happens is we the code that was written for Spark in PySpark is converted. So here is the API which says Snowpark execution. This is nothing but an translation of the code or the plan that was generated by Spark into a Snowpark execution. So the engine which is there, so it is not the same Spark distributed engine which happens in the OSS Spark. It is the Snowpark execution engine that is executed. So people who are not aware, there are other implementation of the Spark execution engine, distributed execution engine, which is there. So for example, there is a project called Data Fusion Comet that also does something similar. They translate the Sparks plan into a Rust-based Rust-based plan. Similarly, there is a project called Gluten, which also translates the code written plan which was written from Spark uh, to a substrate model. It is written in C++, so they follow the substrate model. So they create substrate out of it, and then there is a different engine which runs the code, not the Spark engine. The reason for both of them doing that is because they want to leverage the native engines. For example, C++ is a native means in it's not a JVM system, so that it can directly run on the host. Same way, Rust also is not a JVM based system, so that doesn't have a JVM overheads. Similarly, what Snowflake has done is they have created a Snowpark execution engine, which is based on the native vectorized query engine. So they also want to leverage the same things. So instead of running this warehouse with a Spark cluster, a Spark execution engine, they are just leveraging the plan, and that plan gets converted into Snowpark execution, and that execution happens in a vectorized query engine. And that cluster has access to storage, which is nothing but, for example, it can be Snowflake managed storage or Iceberg. That can be both Snowflake managed or externally managed. Then we have externally managed stages like S3 ADLS or GCP's storage system. So that way we can what we can do now is we can write PySpark code in the IDE suitable for us, or from the clients which are suitable for us, and then run the same code which we would have needed a Spark cluster to run. Instead of using Spark cluster, we will be using Snowflake's warehouse to run that particular code. And the benefit out of this is Snowflake's warehouse strategy is very nice. Like I like that because it spins up very fast, it scales down also very fast, it has all the optimizations inbuilt, dynamically scaling up, scaling down. Even we can have other features, right? Like suspending or one pool of clusters that we can keep. So there are a lot of things which totally removes the work that we would have done if we would have run a Spark cluster ourselves. So this is something which is very good about Snowflake's warehouse. So that the same capability of Snowflake warehouse is now available for Spark users as well. So we can run the Spark code in the warehouse with a speed which will be higher than the open source Spark, and we will get to access the same data which is present in Snowflake. Otherwise, what we would have to done is move the data out of Snowflake and then run Spark workload on there. So this is all about the things which run, how we run. And so the things which is required is Snowpark Connect currently supports only Spark 3.5.x, because the Spark Connect itself is production ready or GA in 3.5. It was available in 3.4 but not GA. It was, I think, in preview mode in 3.4, but from 3.5 the full support came, and even in higher versions it will have more and more feature support. And also there is a gap between Spark Connects and PySpark API compatibility. So the same challenges which are there with Spark Connect also comes with Snowpark Connect. Other thing is that we need to run warehouse runtime version of 2, and Python version on those clusters should be 3.10 3.10 plus. Apart from that, similarly, if we are using any other packages, that has to that has to be compatible with this Python version. How we install is this is nothing but conda create. You can forget, like, this is something which is for isolating the environment. If you have system, like, say if you are running on container environment, you can directly run the installation of Snowpark Connect. This is the package which will have dependencies of all the dependencies which are there for PySpark as well. So PySpark Connect, also you can see, I think there is a dependency on gRPC, some gRPC IO packages, and a few other things, async IO. So those dependency will get installed when we install these things. So if you have system conflicts, that make sure that you have the right versions installed for those things. So once we install this, there are two ways we can define the connection. This connection is nothing but how to understand, like, this picture we see, right? This is the client, and these are the warehouses where it will connect. So to tell how to connect that, that's a connection.html file is needed. We have to create that, and this is a mandate that we have to name it as like Spark hyphen connect. I'm not sure why it is a mandatory as of now, but they will Snowflake can change it in future. And then we provide the host name. This is nothing but your account, Snowflake account, host name, then port and everything, username, password, warehouse, protocol, everything you can select in here, you write in here, or you can have an option of saying Snow CLI. Using Snow CLI, you can say Snow connection add, and you provide these things. It will ask few questions like which is the host, which is an everything it will ask, and then same it will generate the same toml file as well. And if once we have that, we can list Snow connection list. It will list all the connections which are available. And also here, if you see, we can create multiple connections in the same toml file. uh, and we can test the connections as well, whether it is working or not. So this is all about creating the setting up the environment. Once we have set up the environment, this is normal. Apart from this, everything else is normal PySpark code. This is one thing that we have to import the session and Spark Connect. So that's, for example, we import the Snowpark Connect, and using that we create a session. So that's one requirement that is there. Otherwise, everything remains same, like this is creating a data frame and just doing a count. So this, although we write it in our local, this code will get executed on the cluster. Here is another full code, full example, that how we can run a simple PySpark code. uh, some try catch block is there. This is where we are creating the Spark Connect session. And uh, this is where we start the session, and then we get the session with Snowpark Connect.get session, which gives us the Spark. And after that, it's all Spark code that we used to have. The good thing is here, if you see, all the binaries are predefined. So for example, we are reading the table because this is connecting to the Spark at Snowflake's catalog itself. So we can read the Snowflake table or a database table, sorry, schema, then databases and then the tables. So that is something that we can do. There is one more interesting thing that we can do is we can directly read from Spark the stages that has been created for storage integration that is created for Snowflake. So this is nothing but a stage uh, integration dot the uh, I think this is the schema, and this is the location where the file is loaded. So what we can do now is we can upload a file into Snowflake using the stage storage integration, and then we can call that in our Spark function and read do the processing. So we don't have to move data from Snowflake outside. So this is how we can connect and we can run. There is one thing to note is this Snowpark Connect. There is a difference between Snowpark Connect, and there was an earlier tool or earlier offering from Snowpark which is called Snowpark Connect for Spark. This was nothing but a connector which allowed us to talk to Snowflake. So this was the connector. So what it allowed is to read from Snowflake and write back to Snowflake using Spark. So this was the Spark cluster was running in our environment, and if we have to connect to Snowflake to get the data, this was used. And the current solution that is provided is something similar, but the whole computation works on itself on Snowflake. There is no data moving out of Snowflake environment and then coming back to the Snowflake environment. No, it's not happening. It's everything is within the Snowflake warehouse itself. There is one more different thing that I want to highlight is that in Snowpark Connect uh, for Spark, we can directly run the Snowflake queries as well. So let's say if we want to mix and match two things, for example, let's say our pipeline does something, and let's say it inserts data into one particular table, and let's say we have a materialized view of that, and we want to trigger that materialized view directly from the Spark code itself. So what we can do is we can use SQL pass-through. This SQL pass-through simply what it does is that whatever SQLs now will be running after this pass-through is set to true, it will not go to Spark engine, rather than it will directly go to the SQL engine of Snowflake and run the query. So in this example, we have used a command to use a certain warehouse, and then we are running what is the current role, who is the current user, what is the current database, and stuff like that. So this we can do. So this simply shows that we can run a Snowflake SQL command directly from our PySpark code. So this actually helps I see a great benefit out of this is that we don't have to write, let's say, earlier if this was not there, what we would have done is we would have called the Spark function or Spark job to write something into Snowflake, and then we would have a different process, a trigger or a task or a stream task in a Snowflake to do the real-time loading. So instead of doing that, we can directly invoke few SQLs directly from the Spark code itself. Although everything looks very fancy and it's nice, but there are certain limitations of Snowpark Connect as of now. First of all, only Python language is supported, no Scala, no Java support is there. It might come in future, but as of now, it's not. Uh, then whatever tuning or optimizer commands that we will give, for example, if we give a join hint in Spark, df dot we provide the hint that okay, broadcast it or do a shuffle as join. So those are not honored in here. So it's not a limitation per se, because the engine that runs the Spark code is pretty efficient itself. But it's a thing to note that if you have written all those things in your code and you are running that now in on Snowflake, so be aware that those things are not getting into account. Similarly, if we have written lot things like data frame dot repartition, that will also not work in here, because the environment which is running this does not need that repartitioning. It automatically does that for us. So all the repartition commands that are there, that are translated into no op while doing the transition from Spark to Snowpark APIs that I mentioned in here. If you see, the code, the plan from the Spark query optimizer is converted to a Snowpark execution. So that time itself, those things are, for example, if we have given a hint, that will be removed. If we have given any repartition, that will be translated into a no op. So no op basically is nothing but it will not do any action on that. For example, RDD APIs are not supported, and PySpark ML library is not supported as of now. PySpark streaming is not supported as of now, and this streaming is not supported even in Spark Connect. So this is not an limitation from Snowpark. Then we have certain tables that we cannot create. For example, creating iceberg tables from PySpark code is not supported as of now. That table has to be created separately, be it externally managed table, iceberg table, or be it a Snowflake managed table itself. Both the tables have to be created separately. We can do the insert, we can do the update, but we can't do a create statement from the PySpark code. Another thing is that we cannot use schema merge as of now. So this is kind of a bummer that it should have been there, but for some reason, maybe people will, means the Snowflake team will be working on this to enable as well, because these things will actually help Snowflake's adoption of Iceberg as well. So yeah, these are the limitations, and this is how we connect. We can run Spark code on Snowflake. Hope you like it. Thanks. Have a good day.